Hello, welcome to today's Tuva Science Connections, where we're going to be talking about abiotic relationships and looking at mercury and tuna and how we can use data on tuna, something that most of us are familiar with, to get at this MSLS2-2, where we're asking our students to construct an explanation that predicts patterns of interactions among organisms across multiple ecosystems. And a component of those interactions and the patterns is how those organisms interact with the abiotic components of those ecosystems. And oftentimes we think of that interaction in a very positive light, right? Like it is important, we get benefits from the abiotic components of our ecosystems, but it's not always beneficial. And we can use data looking at tuna, canned tuna, something that many students are familiar with. Either they've eaten a tuna fish sandwich, or they know someone who's eaten a tuna fish sandwich, or they have eaten sandwiches and they can kind of think about eating fish, things like that, to get at this question of sort of when do these interactions between organisms and the abiotic components not go so well, to kind of build out a broader sense of what kind of interactions might be happening, what kind of patterns could we see across those interactions. And so we could use data that, similarly to how it's used in the activity, how much mercury is at the top of the food chain, to ask a question like, do the data that we're looking at support or refute the claim that canned albacore and canned light tuna tend to contain the same amount of mercury? So let's dive in and use this data set to get a sense of what's going on. So a little bit of orientation to the data set. The data are from the US Food and Drug Administration, and we can use these data, as I said, to kind of look at bioaccumulation or look at mercury, this abiotic component, and how it affects our top predators within a food chain. There are 39 cases. So in this data set, a case is each time a can of tuna was sampled, and then there are 3 attributes. So let's take a look at what those 3 attributes are. We have the type of tuna, we have the mercury level that was recorded, and we have the year for which the sample was taken. And so we're trying to figure out, do the data support that claim that albacore and light tuna have similar levels of mercury? So these are our types of tuna. We can look at it. Okay, that's kind of funny. So let's get a look at, our bar chart of means. Oh, right. But to have a mean, we need a numerical variable, right? So let's drag our mercury to our x-axis. And here we have our bar chart of our average amount of mercury in albacore and in light tuna. We know that average isn't always the best thing, so there are other measures of center. So let's add a few of those on so we can get a sense of, here's the mean, right? We can see that visually, the difference in the bars. Let's add our median. Let's add our mode. Let's just go for all 3 to get a sense of these centers. Now that's a lot of lines, so it's hard to figure it out. So let's show those labels so that we can see. Okay, so we are seeing that the mean and the median for albacore is greater than the mean and median for light canned tuna. So that's interesting. What we could do is we could play a little bit more into this, right? We're just looking at summary statistics right now of our data. So if we were to change up the kind of plot that we were using, the way that we're graphing our data, now things get a little more interesting, right? Our mean and our median are the same. The data haven't changed. We're just looking at them differently. We're getting a sense of all of these individual points. We're now seeing the raw data, but we're also seeing this 5-point summary in the box plot and all these different summary statistics of center that we had plotted originally. Now we can sort of get into this like, oh, are we as confident that albacore is much higher than light tuna? And so these are ways that we can kind of quickly get in and tinker and play to get a sense of, is there bioaccumulation? Is there mercury in tuna? And which canned tuna might it be showing up in more? So this has a health implication while helping students understand that abiotic organism interaction, that there's mercury in the ecosystem and it is accumulating up into these tuna species. The activity, if you were to go through this, actually walks students through having them think about what is a food chain and how the students, where tuna fit into the food chain. So there's more to that than just that quick interaction and how to play around with the data. But by leveraging sort of those summary statistics, by leveraging color or the kinds of graph types that we're using, we can dive in a little bit more to do the data support or refute this claim, right? So when we were just looking at the summary statistics, when we were just graphing the averages, it very clearly looked like, no, the data refute that albacore and light tuna have the same amount of mercury, right? Because there was that difference. When we looked a little farther, when we sort of looked under the hood and got a sense of what's really going on with the data, I mean, there's still big difference in clumps of where those data show up, but there are a lot of data values of light tuna that overlap with the with albacore. So then you could get into like, well, what do we mean by tend to contain? And what do we mean by the same? And we can sort of dive into those nuances. That how confident are we? What are the data showing? What does this mean for our claim and our confidence in the claim? This, of course, is just one of many connections that you can make with your science content using data from Tuva. So I encourage you to check out the science content library, looking for other life science activities and data sets. You can search by different performance expectations or by different topics, whichever works best for you. As always, if you have any questions, feel free to reach out to anybody at Tuva. We hope you have a wonderful day and enjoy playing with the data. Thanks.